All right. So the today's session is testing throughout the software development life cycle, and the agenda for today's session is I'll be discussing software development models, which will include waterfall, V model, iterative development model, few variants of IDM. Then I'll cover the test levels, different test levels involved into the software testing, which will include unit testing, integration, system, and acceptance testing. And the third module I'll be covering is the test types, or you can say the targets of testing. Okay, so in test types, I'll be covering functional, non-functional, and structural or confirmation or regression testing. So this is the agenda for today's session. I'll try to cover as much as I can because today I have lot many around 50% more slides than the previous session, so I'll try to rush a little bit. Okay, so the first thing is let's get started with software development models. So most of you would be aware of the different development models if you are working in IT company. So you might be aware of different models like waterfall development model, which was the first development model uh, for developing system and software. And then it has some issues, some drawbacks. So to overcome those drawbacks, a new model came in, that is V model. And the latest one which you can see is the iterative development model, in which there are quite a lot of variants like rapid application development, extreme programming, and agile development, so things like that. So we'll start with the basic one, that is waterfall development model. So waterfall development model was one of the earliest development models to be designed. And in waterfall development model, the execution or the software development was divided into a sequential fashion. And the progress of software development was something like, it started from requirements phase, and then after one phase got over, then uh, it entered into the next phase. So it was very sequential kind of, unless and until requirements got finalized, you cannot enter into design. Unless and until design is finalized, you cannot implement it. So it was like something, it was divided into phases, and the phases were like requirements, design, implementation, then testing, then deployment, and then maintenance. So it was kind of complete sequential thing. And uh, you cannot enter the other phase unless and until the first phase is frozen. So unless and until requirements were frozen, you cannot enter into the design phase. Unless and until design documents are frozen, in which you have high level design and low level design of the softwares. So unless and until those are finalized through the by the stakeholders or the architects, you cannot go into the implementation, which is the coding part. So once you enter the implementation, so after every feature that is mentioned into the design is implemented, and developer is ready with the build, then you go into testing. So testing came after 3 to 4 phases. Okay, so this was the drawback of this waterfall development model, that one phase has to be completed, only then you can enter into the second phase. All right, so here's the figure that I have drawn. So these are the basic levels in software, in waterfall development models. So the first one is the requirements gathering. So once requirements got finalized, you enter into the design phase, wherein you can have high level design and low level design. So once design is done, you get into implementation. Once implementation is done, you get into testing. Once testing is done, you go into deployment, and then finally into maintenance. So it was kind of very sequential in nature. And It has a lot of drawbacks, so which I'll address in the other slides. So in requirements phase, what happened was, in this phase end user requirements are captured and feasibility study is done. Okay, so suppose a client wants to build some software system, so he will provide you with certain requirements. So in what if you're following waterfall development model, so that you will contact the client, the business analyst will contact the client, they will capture the requirement, they will do the feasibility study whether those requirements are possible to implement into actual system or software. And once those requirements are captured, feasibility study is done with the stakeholder, with the client, only then you can they prepare software requirements document. And once that document is finalized and approved by everybody, with the stakeholder, with the client, only then you move to the design phase. So in design, what happens in design phases, in design phase you study the requirement, like software developers and architects study the requirements that are captured from stakeholder, from the client, from business analyst. They study those requirements and they design the documents, like they design high level documents or low level software design document, in which they basically explain how will the software look, what will be the different components involved in the development of software, what will be the database like, what different components will be there, what type of communication will happen between the integrated components. So all these details go into design documents. So design documents are of two types, high level and low level. So these design happens into design phase. So once the design is finalized, implementation starts after that. So in implementation phase, developers start coding. So actual coding comes after the design has been finalized. So here like UI developers or backend developers, server side developers, they just go through the design and they understand how to actually implement the design into the working software, into the working code. So in implementation phase, the actual coding starts. So once the implementation is done, so implementation also takes long time in waterfall development model, because it was not kind of that all the requirements had to be implemented, only then they can be handed over to testing. So after all the design, all the requirements had been implemented in implementation phase, the actual running build, the testable build was handed over to is handed over to testing team to start the testing with. So you can see that testing team came after 3 phases, or somewhere in some organizations, design itself is divided into high level and low level. So you can say after 3 to 4 phases of research and discussions, testing team comes after that. So after that, testing starts to test the software. And once the software is tested and all the defects are fixed, and then only then software is uh, suitable to be deployed or to go live. So once testing phase is over, the deployment is done for the software in customer scenario or customer environment. And after the customer deployment, the maintenance part begins, wherein if there are new features, if there are defects found after the deployment, they are fixed, or if there are some upgrades or enhancements to be made, those are made into the maintenance phase. So this model has the drawback in a sense, like testing was not involved from the beginning. And suppose there were certain requirements which are not testable, or they are not feasible, and there is a defect in the requirement itself, so that cannot be figured out if test team is not involved with in the requirement phase or design or implementation phase. So if wrong requirements are being designed and implemented, and then it comes into testing team, uh, it becomes very difficult to fix those defects, because then you have to go back to requirements, change the requirement, change the design, change implementation. So it's a huge, drawback. The cost of fixing defects in this model was very high as compared to the recent models that we have. So because of that, this model was kind of that there were a lot of improvements required into waterfall development model. So we'll discuss why the improvements were required, and what are the new models which are much better than waterfall development models. All right, guys. So let's take some questions. Anybody, any questions? All right. So I would take no questions. Let's go ahead with another development model. That is, so here I'll cover what are the disadvantages of waterfall model. So in waterfall model, testing tends to happen towards the end of the project, as I explained, that your testing team gets the build after 3 to 4 phases. Okay, because of that, the defects were detected very close to the live deployment date, which really made it very difficult to uh, find those defects and fix those defects. So if the test team found any defects which came from bad requirement or invalid requirement itself, so now the requirement has to be modified, then design has to be modified, implementation has to be done from scratch. So the this made the cost of fixing that defect very high in this model. And another disadvantage of waterfall model is requirements or any document, any phase has to be frozen. Only then you can enter the next phase. Right. So these were the disadvantages of waterfall development model. So in order to overcome the disadvantages of waterfall development model, V model was introduced. So V is like verification and validation model. So V model addresses some of the problems found in waterfall model. So it doesn't address all of the problems, but it addresses some of the problems found in the waterfall model. So in V model, what actually happens is the testing activities like verification and validation can be integrated into each phase of product life cycle. Okay, so you can integrate verification activities and validation activities in the whole product life cycle. And there are many variants of V model. However, the common type of V model basically includes like the 4 levels of testing. One is unit, integration, system, and acceptance. These are the main 4 levels of testing. So V model usually contains these 4 levels. So here's the diagram for V model. So what like in waterfall development model, it was kind of more of sequential thing. So in V development model, the change was like test team was involved from the requirement phase itself. So in case the requirements were not clear or requirements need to be modified, so in that case the test team would suggest certain workaround or clarify the requirements. So like when developers or business analysts are busy in capturing the requirements, so if test team is involved, so they prepare acceptance test cases for from the requirements that they are getting. Okay, then in this, right, all right, I'm getting a ping from Nehal. Nehal, are you joining from a phone or something? Or maybe you can drop off and log in again, because everybody else is able to hear my voice. All right. So so after the requirement comes the system requirements, or the design phase, wherein different design documents, high level and low level design documents are created. So test team reviews those studies those design documents, reviews those design documents, and figures out the testability of the design that has been made, and can also provide inputs, whether the design that has been made is proper or not. So in that case, test team studies design documents and writes system test cases for system test execution. Then comes the global design. So in this global design, you can say high level design is done, and in this phase, testers write the integration test cases. And when comes the detailed design, that is low level design, so in this case, testers design unit test cases or unit test execution test cases. So this model tried to address the issue that was into the waterfall model, like testers were not involved from the starting of the phase, like from the requirements itself. So in V model, testers are involved from requirements phase. So the defects, or the defects that can come from requirements or design or system requirements or design documents to implementation phase, are reduced a lot, because those documents are reviewed, verified, or validated by the test team, um, while they are creating different test cases: acceptance test case, system test case, integration test case. So the chances of getting defects after implementation are reduced a lot, or chances of getting defects which can occur due to bad requirement or invalid requirement or invalid design are very less. So in this case, the chances of defects like coding defect or implementation defect are mostly seen. So in this case, you will find like the cost of fixing those defects won't be that high, because cost of defect is high only if you are implementing a wrong requirement or you are implementing a wrong design. Okay. Any questions? Okay. All right. So as discussed in V model, they try to cover 4 test levels. So the first test level, that is unit or component testing. Second is integration testing. Third one is system, and finally the acceptance testing. So I'll take a brief about these test levels. So the unit testing is basically, it searches defects for the software components, basically module, programs, or objects or classes, very very small testable item, you can say. It's the any module or class that you can test is known as unit or component. Then comes the integration testing. So integration is it comes after unit testing as well. It comes after system testing as well. So the integration testing that comes after unit testing is unit integration testing, and the one that comes after system testing is system integration testing. So here I'll cover integration testing that comes after unit testing. So in this integration testing, what happens is like in unit testing you have already tested separate modules, testable modules, and then in this phase this is usually done by developers using more of coding and programming knowledge is required, because they write different stubs and drivers to do integration testing. So they basically test the interface between the components in integration testing, or the interaction to different part of the system, like operating system or file system. So in integration testing, the interface between different part of system or interface between two units is tested. Then comes the system testing, in which after the integration there are you can say bigger modules available. When those modules are integrated, or those modules are taken as a whole, or system as a whole, or software as a whole is given to the testing, then comes the system testing. So in this system testing, what's done is the product is tested as a whole. The main focus of system testing is to verify the software requirements or specified requirements in the requirements document. Whatever requirements came from end user or the stakeholders are being implemented properly. So the main focus of system testing is to verify whether the requirements that came from end user or stakeholder or customer are being implemented properly. So after this comes the acceptance testing. So in this phase is this is basically the validation part. System testing is verification. You are verifying whether the software requirements are being implemented as they are specified in software requirement document. Then in acceptance testing, you are validating with respect to end user needs or requirements or business process. Like suppose you developed a banking application, and the requirement that is mentioned in the requirements document has been fulfilled, but end user need is to like if I'm withdrawing money from ATM system, so I should be able to withdraw the money successfully if I enter my PIN correctly. So the business process is basically like when you're doing any transaction end to end, or end to end, like in you put your card into ATM, put your PIN, correct PIN, you withdraw money, and the balance in your account is perfectly the calculation and balance in account is perfectly fine. So this is whole end-to-end user scenario which end user or the banking user will do. So in acceptance testing, these kind of scenarios or the business process comes, like if end user is withdrawing money from ATM or withdrawing money from internet banking application, so all that those scenarios are the business process should be successful, and there won't be any calculation issue or the issue with the account balance and something like that. So these kind of scenarios come into acceptance testing. So after this comes iterative or incremental development model. So this is the recent one, you can say. So in iterative or incremental development model, what the idea is, because in previous two models you have seen, the software development was the cycles were of around 1.5 or 2 years minimum. In my past career, I have worked on waterfall development model, I have worked on V uh, development model, and then finally in iterative and agile as well. So in starting of my career, I when it was more of a V development model, the cycles were of around 1.5 year, something like that. So those were kind of very long cycles to develop a software or system. So to overcome those things, the end user was able to find a working product only after 1.5 year or 2 years. They have to wait, and you never know when your competitor launched the product already in the market and captured the market share. So to address all these things, to address the issues with previous models, iterative or incremental development model came, in which so instead of one large development life cycle, the whole project was divided into self contained smaller cycles. So in this model, the delivery of the whole software was divided into smaller chunks or increments or builds, and each build added some new functionality. So uh, the implementation is basically like, you prioritize your requirements, you implement the highest priority requirement first in first cycle, you deliver those are tested, those are given to the end user or stakeholders, so they are able to see some working code or some working software very soon, rather than waiting for 1.5 year or 2 years of complete cycle. So that's the advantage of iterative incremental development model. There are many variants of these models. Now in this model, here's the diagram that I have picked from my blog itself. So like you can say it's divided into phases. All right, so phase can be, they can, in some organizations they are of 1.5 month phase. uh, I have worked in an organization where these phases were of around 2.5 3 months as well, in which independent requirements were there, then requirements, then design, development, build, test, and deployment. So each phase has independent set of activities to be done, and then in next phase again, new requirements, new development to the existing, which contain new requirements, the new build and test and deploy. So that was kind of incremental development. So subsequent increments will need testing for new functionality. So like in phase one, you prioritize certain requirements and you implemented those requirements in phase one. Those got tested and you got some working software being deployed. Okay. Then in next phase you get new requirements which are less priority requirement. Uh, you start with those requirements, you develop those, build those, test those, and deliver those, deploy those. So in each subsequent phase, you need you will be getting new functionality, and you will be doing regression testing of the previous phase as well. Like since you are implementing new functionality in second phase of the software, so you need to do regression testing as well as integration testing of both new and existing functionality, the existing functionality from phase 1 as well as the new functionality from phase 2. All right. So iterative development model gives market, early market presence. So the issue seen in previous models like V or waterfall model has been removed with this, because the phases are of very less time, like 2 months, 3 months time period, or even less in agile development model. So after that period you get something working, some working code which can be either delivered to the market or can be shown to the stakeholders. So you get continuous stakeholder feedback in this model. All right, and you get continuous feedback from end users, what your users are liking about your product and what they are not, rather than waiting for 1 year and then finally you get to know, okay, these are the features that my users didn't require, never required, or they don't like. So those are the things that can be addressed in incremental development model. All right guys, any questions? No questions? Yeah, so Nehal has one question. Is it agile methodology? Nehal, agile is a part of incremental development model or iterative development model. Agile comes under iterative development model. So iterative development model has many variants, which I'll take in subsequent slides. So like in this slide you can see examples of iterative development model are rapid application development and agile development. So hope this answers your question, Nehal. I'll cover, yeah. So rapid application development and agile are both part of iterative development model. There are few more which you can Google, like rational unified process is also iterative development model. Okay, one more question from Tane. I know regression testing, but how it works in iterative development model? Okay, let me go back. All right, Tane. So suppose in phase one, you have certain requirements. You did design, you prioritize certain requirements. You developed design docs. You implemented that, provided build for testing, deployed it. You have something working, some working code. Then in next phase, when next phase comes, so in first phase you will be testing and there will be certain set of test cases which you will be writing and maintaining it in tool. So in next phase the new functionality will be implemented over on top of the software that was delivered in the phase one. All right, so in second phase the you will be testing the functionality that is newly added, as well as you will be also doing regression testing of the existing functionality that was developed into phase 1. So to make it more clear, like the test cases that you developed in phase 1, you need to figure out the test cases, the regression test cases that need to be executed in each phase. So like here, the in phase 2 the testing cycle will be more. In the diagram is it's not clear, but in every phase the testing cycle will be more. The duration of the testing cycle will increase because you have to execute the new test cases for new functionality in each phase, as well as you have to do regression of the previous functionality as well. Does that answer your question? All right, so regression set or regression suite you have to start creating from phase 1 itself. You have to figure out the test cases which will go into regression suite, and those regression test cases have to be executed in each phase, and those regression test cases, new regression test cases has to be added in each phase as well. All right, so regression test cases are the best candidates for automation because in every phase you have to execute those test cases. All right, so the selection for regression test cases. Okay, how many regression suites will be in one project? uh, Only one regression suite. It depends, Shilpa. Like regression suite, uh, you can define according to the functionality, like UI regression suite or server side regression suite. But for each functionality, like server side regression suite will be different, UI regression suite will be different. So if you divide them according to the module, there can be 3 or 4. So for UI you can maintain one suite, for server side you can maintain one suite. So it's like that. Is it clear, Shilpa? All right. So shall I go ahead? Any more questions? Cool. All right. So I was with rapid application development. So in rapid application development, what happens is, suppose you have a set of requirements which needs to be implemented. So in RAD, what happens is the components are developed into parallel in time boxed cycle. All right. So instead of like in iterative development model, like we prioritize certain requirements, and then we added few more requirements in next phases. So that doesn't happen in rapid application development. What is done in this is, uh, all the features or the components that need to be developed are divided, and they are developed parallelly. All right. Like UI is developed at the same time, server side is also being developed. Okay. So server side UI are developed parallelly, and at the end of the cycle, time box cycle, all the components, all the functions are integrated into one, and they are assembled into a working prototype. Okay. So when they are assembled into one, you get a working software. So, and when you get a working software, so in RAD there is not much importance given into testing, because this is just this development model is just to give a quick understanding to the customer, uh, that this is how the software will look, this is how the prototype will be, what you are expecting, so that customer sees and gets a feel of the software and provides feedback. Okay, this is how it is, and this is how I want, change it like this. All right. So he can suggest what functionality he needs in future releases. So this is basically to not to waste time, develop different components parallelly, integrate them within a month and a half, give a working prototype to customer so that you get early feedback, and you understand the exact customer requirement, what he needs. All right. And what future functionality he needs in future releases. So that's what rapid application development is. And RAD, rapid application development, is part of iterative development. Yeah, Ramu. So, agile, rapid application development, rational unified process, then extreme programming, all of these come, under iterative development model. So all of them are, kind of under similar lines. So right nowadays, agile development is kind of the most preferred development model by every organization, even though every organization has tweaked it according to their uh, convenience or so, but uh, I didn't get you, the talk of the town. I didn't get you, Ramu. What do you mean? All right. Okay, so the next one is agile development, which is the latest development model, and nowadays followed by a lot of companies. Yeah, yeah, Ramu. Agile is the hot topic nowadays, and it's a very preferred development model from all the organizations because there are a lot of advantages that agile development provides. So agility is basically rapidly to adapting to changes rapidly and efficiently. So agile word came from the word agility, and this means that how efficiently and how rapidly you change to the you adapt to the changes. So in software development context, if I talk about this means how rapidly and efficiently you can adapt to the new requirements or changes in the requirement. Because if you compare the previous development models like waterfall and V, only after requirements get frozen, you get into next phase, and if there is a change in requirement, it was very difficult to adapt or implement those changes into the later phases. So because of that, to address that, agile development came into practice. So in agile software development, this is also based on iterative or incremental development. Then it uses continuous stakeholder feedback to produce high quality consumable code through use cases. So in agile, usually what the how the development works is the stakeholders or end user provides you with the user stories or use cases. What are use cases exactly? They are requirements, you can say, in the form of stories, like uh, as an administrator of CRM software, any HRMS or CRM software in a company, I should be able to add new user into the company, new employee into the company pool. Like I should be able to add a new employee to the HRMS database. So this is a story. This is a use case or a user story that comes from end user or from the stakeholder. So you get requirements in form of user stories or use cases. Then these use cases are discussed within team for the feasibility, if it is feasible to implement those. And once the use cases or user stories are finalized, then comes different phases. So in agile, it's I if you guys want, I can take a totally different in-depth agile topic, but this is not kind of session wherein I should go into this deep. So what I'll do is, once ISTQB session is over, I maybe take a session or two on agile development as well, because agile development itself is a 2-day module or 2-day course. So I'll give a brief about it. So it uses continuous stakeholder feedback and through use cases. And in agile, basically the small time box iterations of 2 to 4 weeks are there. So you get use cases, and then you have a small sprints of 2 to 4 weeks, depends, like um, in my previous organization we had sprints of 3 weeks each. So there were sprints of 3 weeks each, in which requirement analysis, design, coding, everything is done. And then the acceptance criteria is also decided in that time box iteration itself. And then you have to showcase, you have to do demo of what you developed, what you tested, all right, to the stakeholders. And once stakeholders are satisfied what has been developed in 3 weeks, the working code, then you start with the next sprint. wherein you again plan, you do task, you divide, you take up the user stories, you create tasks, developers create development tasks, testers create test tasks, and you again start working in those time box iterations. And the team size in agile development is very small, maybe 5 to 10 people, not more than that, because it makes collaboration easier. And in agile development there are daily stand-up meetings. So those are very important, known as scrum meetings. So these are just 10 to 15 minutes meeting, wherein you just need to say what you did yesterday, what you are planning to do today, and are there any blockers. So the benefit of these stand-up meetings is, since you are a small team, everybody is accessible. If there are any blockers, whole team, if anybody is aware of how to resolve those blockers, will help you out, and you can, once the blocker is resolved, you are good to go with the next task or next story. So this is very, very brief about agile. The main thing is the continuous stakeholder feedback, because when after 3 weeks of sprint, when you do a demo, uh, it's a working code, or it's a working software that is shown to the stakeholders or the end user, and then he gives you proper feedback. Okay, this is implemented perfectly fine, these are the changes which I need, which you can easily adapt to, which you can easily change in next sprint. So that is why agile development is the most effective and efficient development model nowadays, because uh, efficiently and rapidly adapting to changes, incorporating feedback from the end users, and it's very kind of, you get working code in just 1 or 2 sprint time, you get working software in 1 or 2 sprint time. So that's the advantage of agile development. So maybe once this session is over, I'll take a complete different session on agile development, don't worry about that. So what's the question topics like? Agile testing process, testing method, agile testing, agile bug tracking, agile test reporting and release. How does concept of regression work in agile testing? Okay, so Ramu, the concept of regression is kind of same as I said in iterative development model. Agile is also part of its iterative development model. So like in time box iteration, in agile it's 2 to 4 weeks, it depends. So suppose you have 3 weeks of sprint, then in first sprint you developers developed something, you written your test cases and you tested something. So you have to maintain the test cases, or the test cases that you have written in the first sprint. You have to figure out the regression candidates for the next sprint. So you have to prioritize your test case, and you have to come up with regression suite for next sprint. So as it was discussed in iterative development model, same way, that regression suite from sprint 1 will be executed into sprint 2, and then in sprint 2 as well you will be adding few more test cases in regression suite that will be again executed in sprint 3. So that's how it it works. Is it clear? Ramu, is it clear? All right, let's go ahead. Okay, so testing within a life cycle model. So we have discussed a lot of development models, uh, right from waterfall, the first one, to V, and then iterative development model, wherein a lot of changes came in. So what are the characteristics of good testing? So if you talk about characteristics of good testing, so for every development activity there is a corresponding testing activity. So You can improve testing only if whenever there is a development activity, like development team is involved into requirement phase, so corresponding test team or test activity should be involved in requirement phase as well. So it should be mapped properly. It should not be like uh, test team is involved after 3 to 4 phases. Then each test level has test objectives specific to that level. So like I discussed unit integration, system and acceptance test levels. So each test level should have different test objectives specific to that level. Like in unit testing, the objective should be to uh, test unit test cases, or execute unit test cases and fix any unit test defects before entering into the integration phase. All right. So each test level should have clear objectives for that level. Then the analysis and design of test for a given test level should begin during the corresponding development activity. All right. So it's kind of related to the first point itself. Like your test design or test analysis should begin um, once the development activity for that phase starts. Like if development um, team is working on requirements phase, so you should start creating the test cases or acceptance criteria. Then if there are the design documents are available, you should start writing test cases for system testing. So whenever development team is involved or doing any um design or work, or they are writing any document, test team should start analysis and design of their test cases. And testers should be involved in reviewing documents as soon as drafts are available in the development lifecycle. All right. So testers should be involved in reviewing the documents as well. So once the draft is available, you don't need to freeze the document to hand it over to test team. First draft is available, include your test team. That way you'll make sure that the software that you are designing or you are developing won't be uh, breaking, or the wrong requirements or wrong design won't get implemented if you involve testers from the beginning, from the draft phase itself. Right. So Ramu says, please touch base on what is difference between these terms: test objective, test scenarios, test case, test condition. All right. All right. Let me cover first the life cycle model. And these are the terms basically, Ramu. Um, so I think these terms will I'll the important terms I'll make a different slide, or because these terms, if you read the glossary of the book that I told, you will be able to very easily understand. Or if you want, I can create a different slide which will cover all the important terms which are very confusing and asked in the exams. Okay, so test levels. So as I discussed in previous slides, there are 4 main test levels. First one is component or unit testing, second is integration, third is system, and fourth is acceptance. Now component or unit testing. So component or unit is the smallest testable part of the software, so that is known as unit. And unit testing is done to verify the lowest independent entities in any software are working fine. So unit testing is mostly done by developers, and this test, unit testing or component testing, tests whether the smallest independent testable item or testable code is working perfectly fine. Right? Like you can say it as a Java class or something like that. So they write different code to test if so I'll cover that stub and driver thing in later slides. So smallest testable part is isolated from remainder code and tested to determine whether it works correctly. So unit in unit testing, it's the unit or testable code is completely isolated and tested uh, without being included in remainder of the code. All right. So suppose there is a class to add two numbers, so that will be tested completely separate. It won't be included with remainder of the code. So that's how unit testing is done, and this is mostly done by developers or white box testers. Okay, so in unit testing, you might have come across these terms, what are stubs and drivers. So suppose you have two modules, you can say two units, A and B. So what exactly stub is? Stub simulates the called units. Okay, so in the figure above there are two units, two modules A and B. Suppose A is being developed, A is ready, and we need to test it. And the module B is not yet ready. Okay, so in that case, if a developer wants to unit test module A, how he can do is he can write a dummy module which simulates functionality of module B and then return that value to A. So stub can be something, or the call unit can be something as simple as returning a value, return some value to uh, another module or another function. Okay, so stub is something when the called unit is not present. Okay, like you have a function or you have a class which needs a return value, uh, return integer, something like that. Then you write a stub which returns that value so that you can test your module A. All right. Then what are drivers? Drivers simulate the calling unit. So suppose module A is not developed, but module B is completely developed. So in that case, you want to test module B because module B has been developed completely, and in such cases the calling unit is not developed, like the driver module A is not developed. So when you write a driver to test module B. So in this case, all right. Okay, so here the developer will write a dummy piece of code for module A which passes the test input to component under test, that is the module B. So in the driver case, you are pushing something to the other module, and in first case like stub, you are returning something to the first module, that is module A. So to understand these things easily, these are mostly done by either white box tester or developers. So in foundation level, these are the questions that can be asked. These are a bit tricky questions. So to make it more clear, you just need to remember stub simulate the call units. Okay, it can be simple as returning a value to first module, and driver is calling something. Driver simulate the calling units. So suppose module B is ready and driver wants drive so developer will write a dummy piece of code, and which will then pass the test input to the component or the other component, that is module B. So driver will be pushing some inputs to the unit that is available, that is module B. So am I clear? Okay, Ramu needs an example. Okay, so in the case of stub, As I said, it can be as simple as the return value. You are passing like in module A wants some return value, or there is a function which needs a return value to test. So you just write a simple code to return a value. Okay, so that's the example of stub. And in the case of driver, suppose you have a game application wherein you in that application you write something, you write a function to uh, just a sec. Can you take up login screen example which may be easy to understand? Okay. Okay, so in case of login screen, I would say there would be a UI. Suppose that there in login screen example, basically there are three layers. A data access layer, then there is a login module in between, and there is a UI. Okay, so if I take a driver example, so in case of this login module, suppose the middle module is being developed, like the login is already developed. So in case of driver, you don't have UI being developed. Okay, so you will write a dummy function which will act as a driver to push the login username and password to the login module that you have written, and which will eventually pass it to the authentication layer and give you the test results, whether authentication successful or not. Am I clear? So basically UI is not developed, then yeah. Ramu, did you got it? Okay, so in case of stub, you can say you have suppose you have the UI being developed, all right, and the login module is not developed. So in that case, you are passing some values, or you need a dummy code that will act as a login module. So you will write a stub that will act as a login module, and since UI is already developed, so you will pass in the username and password from UI, and the stub, that is your login, that is your logic for login module, and that will pass into the um, login validation not developed. Yeah, so in that case, yeah, so if login validation is not developed, so in that case you need a stub. Yeah, that's what that's where the stub comes in. Any more questions? This is bit, stubs and drivers are a bit tricky thing, um, and these are more of if somebody has done development, he would be very easily be able to pick all these things. All right, so shall we go ahead? Okay, so the next uh, phase is integration testing. So in integration testing, tests the integration testing test interfaces between components. So after unit testing comes integration testing. So as I talked in beginning itself, that integration testing can be of two types, like component integration testing that is done mostly by developers, or it comes after unit or component testing, and then system integration testing that I'll cover in later topics, maybe later modules, and this is done after system testing. So once the system is available as a whole, then you integrate it with different softwares or different OS, and then different hardwares, and see how the behavior is with different environment. So in integration testing, the individual tested units are grouped as a one interface, grouped at one, and then the interface between those units will be tested. And integration testing identifies the problems that occur when the individual units are combined. That is, it detects the problem interface of two units. Okay. So you have tested your units perfectly fine. Your units are working correctly. But in integration testing, you integrate those units and you test the interface between those units. Okay, like the return value is being passed properly and is being accepted by different module, another module, and the result that is uh, given after integrating both units is perfectly fine, what you expect. Okay, so that interface is tested in integration testing. Then comes what are the approaches to do integration testing. So in integration testing, there are many approaches. I have taken three approaches. Then the first one is top-down approach, second bottom-up, and the functional incremental. There is one more big bang approach. So that you can Google and study all the various types of integration testing that can be done. So in top-down approach, um, it tests the integration from top to bottom. Like if I take the example of the GUI, so you start integration from GUI, the topmost component, the user interface, and then you add the missing components. So missing components can be substituted by stubs, and integration will go on. Okay, so this is the top down approach. And then in bottom up approach, you start from the bottom of the control flow, and higher level components are substituted with the drivers. Like you start with the lowest component, like server side implementation first, and then you integrate different missing components with drivers, like the example I took before. So in bottom up approach, it is the other way around. Then functional incremental, integration and testing takes place on the basis of the functions or functionality. Okay. So in functional incremental, you have functional documentation. Okay. And according to that functional documentation, functionality is developed, then integrated, then new functionality is developed, integrated. So this is more kind of documented integration testing. So you have the functional specification document, and you develop those functionalities, you integrate those, you develop new functionality, you integrate those. So third one is that. And then the other one I'll share that as one, like big bang approach, in that all the units, all the modules are developed, and then they are integrated all at once, and then the whole system is tested, how it behaves after integrating all the units together into one go. Then comes system testing. So in system testing, you test the system or software as a whole. Okay, you test basically the requirements that are defined in the software requirement documents, they are implemented properly or not. So software requirement specification are implemented into system or software developed. So the main focus of system testing is whether the customer or end user requirements or the stakeholder requirements are being fulfilled. Okay. Then system testing is done after integration testing, and system testing considers both functional and non-functional testing. So functional testing, like the functionality, wherein end user stories or the user scenarios I talked about, like if as a bank internet banking end user, I should be able to transfer amount from my account to any authorized account uh, I have. So this thing is the functional thing. The non-functional thing is the performance of the application. You load the application with a lot of if it's a web-based application, uh, you load it with huge number of users and then test the behavior of the user. Okay, so these are the non-functional: performance, load, usability, how easy is it to use the application, how easy is it to understand the application. These are the non-functional aspects of the software. So system testing considers functional as well as non-functional testing both. Then comes acceptance. So in acceptance testing, this is performed after system testing is done and all or most of the major defects have been fixed. Okay, so once system testing, all functional non-functional testing has been completed in system testing phase and major defects have been fixed, and then comes the acceptance testing. So in acceptance testing, the main criteria, the main target is to build confidence in the software, uh, and to make sure that it fulfills end user requirements or the customer requirements, or it is fit for use. Okay. Then it is done by end user, customer, and maybe some project stakeholder. And acceptance testing is done in production kind of environment. So uh, is specification based testing same as system testing? So specification is the functional, yeah. In system testing, yeah, uh, in system you in system testing you test specifications that are mentioned in your requirements, so software specifications, and as well as different aspects like I told, load and performance testing as well, or usability as well. So there are a lot of aspects that come into system testing. So this specification based is you can say a part of system testing. It's not same as system testing. All right. Okay. So acceptance testing. For commercial off the shelf softwares, so what are the COTS software? These are the software which are uh, meant for mass market, like you can say Gmail, any mail client, or there are many other mobile applications available nowadays. Okay, so these software, the acceptance testing for these softwares is done into two phases, you can say alpha testing or beta testing. So in alpha testing, all right guys, my laptop battery is going down, so okay, so I'll cover a few more slides and then maybe we can reschedule the session some other day. It's already more than 1 hour. Okay, so in alpha testing, it is done into the development environment itself and on the developer side, and the potential user or members or potential customers are invited in the organization itself, and they are asked to do the testing, to use the system to report defects. So that's how alpha testing goes. And in beta testing, this is also known as field testing, and this is done by potential or existing customer. Okay, like any mail client, like when Gmail got launched, it was into beta phase, or any e-commerce site any new e-commerce site, when any organization launches it, it launches it in beta phase, so that the users or the end users which are going to use that application or the e-commerce site, they can basically use and report the defects or report the issues uh, to the organization. So beta testing is also known as field testing, and it is done by potential users or maybe existing customers in the external site without any developer involvement. And this testing is used to acquire feedback from the market about your application, about your e-commerce site. So this is the best way to get the accurate feedback from the end users or the users who will be using your application. Okay. What is commercial off the shelf? Is it one kind of different software? Commercial off the shelf is something which you can which is meant for end users or mass market. That is known as commercial off the shelf. Like the mobile applications are COT software, or any software which any organization can just buy and start using it, like many test management tools nowadays, Jira, and there are a lot of applications which you can just start, you can buy and you can integrate with different applications. So those applications which are meant for mass market are known as commercial off the shelf. Yes, MS Office. So any software which is meant for mass market is commercial off the shelf, which is developed taking into the consideration that it is for the mass market. All right, like enterprise applications, Oracle, IBM, and different organizations which develop enterprise applications, they develop it for some specific purpose, specific banks or something like that. But commercial off the shelf is meant for lot many people, end users. All right, so test types. I think I'll cover this. Guys, can you shall we go ahead with this, or shall I reschedule? Anything special needs to be done while testing SAP or Oracle apps? Ramu, testing is context dependent. I think I covered this thing in last session. So it's context dependent means if you are testing a banking application or if you are testing a finance application, the testing done to test those applications would be different. Phases will be same. The basics that we are covering, the types and everything would be same, but the way you will test those applications, like SAP or Oracle apps, the way you will test SAP and Oracle apps would be different from the way you will test directory server or Microsoft Active Directory. All right, the way you will develop this life critical softwares like air traffic control will be different from the way you will test MS Office or any other Word Microsoft Office product. So the concepts will be same, but the way the tools you will be using to test those applications will be different. Okay guys, STLC is same in any testing. Yes, STLC is same in any testing. Yes, but the context changes as the domain changes. All right, so I'll reschedule this meeting maybe in a day or two, because uh, maybe Tuesday or Wednesday I'll cover the remaining part, and then I'll also start a new part as well. So is it fine for all of you to attend on weekdays? All right.